About that it cut off, and I was using I'm using a new device and it cut off. So I hit a power button on accident. So here we go. We're going to do C and D and the reflect questions. So graph of f of x minus h is where the parameter is the parameter. So now we're going to let h equal 2, meaning that we're going to do g of x equals f of x minus 2. Notice we're taking something away from the x. Complete the mapping diagram and then graph g of x. To complete the mapping diagram, you need to find the inputs for g that produce the inputs after you subtract 2. Work backwards from the inputs for f for the missing inputs by adding 2. In general, this is how the graph of g of x equals f of x minus h is related to the graph of x when h is a positive number. So you'll notice that to get from here to here, we subtracted 2. To get from there to there, we subtracted 2. We're basically having to say, what would I have to subtract 2 from to get 3? That would be 5. What would I have to subtract 2 from to get to 5? That would be 7. So we're going to go ahead and plot that. This was the input for f. This is the output that, input for g, output for f. Okay, so we're going to go ahead and plot, making sure I'm plotting the right thing here. I am going to plot I'm going to plot 1 for negative 2. So I'm going to go out 1, down 2. That doesn't seem like I'm doing the right thing, does it? Yeah, it is. Okay, I'm looking at the answers. And then I'm going to go out 3, up 2. So out 3, up 2 is going to go there. Then I'm going to go out 5 and down 2. And then I'm going to go out 7 and up 2. Oh, that's 6. Sorry. All right, now let's look at what happened here. So I'm going to go ahead and sketch it. So we've got our graph, and notice it still shifted, but it went to the right instead of up or down. And notice that this was different because we were adding and subtracting within the parentheses, whereas on these ones we were outside. It was a Y movement when it's outside, but when it's inside the parentheses, it's more of an X movement. So we would say when H is positive, the graph translates, in this case, we went 2 units to the right. Guess what happens if we were negative? We would probably go the opposite direction, right? We would go to the left. Oh, and guess what? That's the exact conjecture we're supposed to be making here. How would you expect the graph of f of x to be related to the graph when h is a negative number? So we would expect the graph to translate left. Translate to the left. All right, let's look at the reflect questions really quick. So suppose the function f of x has a domain of x sub 1 to x sub 2 and a range of y sub 1 to y sub 2. When the graph of f of x is translated vertically k units, where k is either positive and negative, how do the domain and range change? So when we translate it in the y direction, notice that the x values didn't change at all, right? They stayed within the same range, but same domain. They stayed within the same numbers. But the range values definitely changed. So the range values would change. Let's see. So what did it say? They would go, the range values changed by k units. So range values would change by k units. Suppose we had this domain when the graph is translated horizontally, where h is either positive or negative, but how do the domain and range change? Oh, we want to say the domain same on this one, huh? Domain same. So on this one, notice The range values stayed the same, but the domain values definitely changed. They changed the H units. So range the same. Domain values would change by H units. All right, you can transform the graph of f of x to obtain the graph of g of x equals f of x minus h plus k by combining transformations. Predict what will happen by completing the table. So translate, so if we go positive, positive, so, notice this. This was interesting, wasn't it? Let's go back to this one real quick and talk about this, okay? So notice that we were putting in a -2. So if I were to write the equation for this, it was, actually they told it to us, right? It was g of x equals f of x minus 2. So I put in a minus, but I went in the positive direction. If I put in a positive, or sorry, if I put in a negative, so that would have made it something like that. Notice it changes to a plus line, but I go in the negative direction. So when we're inside those parentheses, we do the opposite shift. But when we're outside, notice it didn't make it. It was the same, right? I had +4, I went up. I had -3, I went down. So that's a little bit different between the x's and the y's. So plus on the x means we go right h and up k. All right, plus on the h means we translate right h and down k units. Okay, so if plus goes right, that means that minus is going to go left. So translate left h and up k units, because it's a positive. And then this one's going to be translate left h and down k units.